Hi, John Masonbrink with PHC News and Plumbing Engineer, back at the AHR show in Las Vegas. I'm at Victaulic's booth with Rodney Young, and he's going to show us a little bit about this hydronic balancing solution. Rodney, take it away.
All right, thanks, John. Basically what we have here is we have a little loop set up. So we have a circulating pump. We have a couple of valves here that represent a couple of rooms hanging off the mains. We have an SDAP setup, which I'll detail in a second. Then we also have a couple of valves here, which would be like a couple of rooms down a hallway inside the circuit. And what we're going to do is we're going to measure out this valve with a TA scope. It's a new meter from Tuer & Anderson. So first thing we're going to do is we're going to hit quick measure here. And when we do that, it comes up. We have the option of checking flow, differential pressure, temperature, and even power. So we can actually measure the power usage on a circuit with this unit. So if we hit measure flow, this is our design data here, so we have it set for 1 GPM. That's what the engineer has specified. We have a 1/2 inch TA valve. It's set currently at 2 hand wheel turns, and the media is water. If it had ethylene glycol, propylene glycol, we could actually just scroll down here to water, hit enter, and it'd pop it open, and we can put in 30% glycol solution, okay? And then it'll automatically correct for the flow rate. So we want to measure this valve, so we hit measure. We're measuring a new valve, so we calibrate the sensor, it vents the air in the lines, we're ready to go. Calibration's ready. So right now we're running 0.8 GPM at 3.55 feet ahead. That's how fast we can get a measurement out of this valve. Now, we're at 81% of design flow, so if we want to reset this, we can adjust the handle and the hand wheel position here till we get 1, or we can do computer method, where we hit options, computer method, we shut the valve quickly. It takes a differential pressure reading on that valve with it shut. We hit done, continue, adjust it to 2.28 turns. So we open that valve right back up to 2.28, continue. We're 0.991 GPM. That's how fast we can reset it. The SDAP set up here, this configuration stabilizes the pressure inside of that circuit so that if you have changes in your pump, your load during the day, your VFD is ramping up or down, it'll actually compensate for that and maintain a stable differential pressure across this circuit. So the high pressure side is connected to the crown. The pressure inside the crown is equal to the high pressure side. So as the VFD ramps up, pressure is transmitted through, the valve will shut down and restabilize this for whatever pressure we have it set to. So that way your ATC valves are seeing much closer to design pressure drop. Also your manual balancing devices, your fixed orifice devices, are seeing very close to their design pressure drop as well. This helps maintain the energy efficiency of the system, but also improve your ATC efficiency so they can meter down into the nether regions, which saves pump head in the long run.
Well, great. That's great. Thank you, Rodney.
Sure.